So we're going to go to page 50, and we're going to get into the actual breaking of the code. So remember, DNA is this code, but we're going to use the code to actually build a protein. And so if you look back at your notes before, you had this central dogma, the idea that we're going to go from DNA to RNA to proteins. We're not turning the DNA into a protein. We're actually going to use the DNA code. So on page 50, we're looking at step 1. So protein synthesis will happen in 2 distinct steps, transcription and translation. And so we want to know that transcription occurs in the nucleus, and the purpose is to rewrite the DNA as mRNA. And we do want to know that we're rewriting just one section called a gene. So we don't rewrite. It's not like replication. In replication, we're copying the whole DNA strand. In transcription, we're focusing on just one gene, one part of the DNA, and we're going to rewrite it. And the other thing that we mean by rewrite is to base pair. Base pair. Rewrite really means to base pair. And so we do this because DNA can't leave the nucleus. It needs to stay in the nucleus, but it does need to send the code. So mRNA is the messenger. It's going to carry the code. So let's circle the M and let's remind ourselves that M means messenger. And that's one of the differences about RNA. RNA is mobile. It can move. It can leave the nucleus and go and move around the cell. DNA stays right there in the nucleus. So we do want to know that DNA can't leave the nucleus. Well, if we're using DNA, that does tell us that transcription happens in the nucleus. So you need to know the who, what, when, where, why of protein synthesis. The who is we're taking the DNA code and rewriting it as mRNA. The where is the nucleus. The why is to send the code out of the nucleus. Now there are a couple hints here in this word transcription if we look at it. If you look at the word script, script has to do with writing. So transcription is when we rewrite the DNA as mRNA. I also want you to notice the C because our second step is translation with an L, and transcription has to come before translation. They're alphabetical too. That will help us. So this first stage is transcription. And so we're rewriting the DNA code. Well, how exactly do we do that? Enzymes will unzip one section of DNA, just one. Remember, what we mean by unzip is break the hydrogen bonds. So we're going to unzip or break the bonds of just this section. And then mRNA nucleotides. Now we do have to be careful. These are RNA nucleotides. So that means that they have ribose, that's where the R is, and they have uracil, not thymine. So remember, no thymine. So we're going to be base pairing, and you can see it here in this picture. You can see that we're going to be using our base pair rules, C and G, but we can't use T. So while there still might be T's in DNA, a T would still match with an A, but if I have an A, I can't add a new T to the RNA. See, this RNA is being built one letter at a time, one nitrogen base, one nucleotide at a time. And I can't add any more T's because RNA does not use thymine. So we're adding this one section at a time. So let's take an example. Let's say that the DNA is CCGATA. Now how would you know that this was DNA? If I didn't tell you, you would know because you saw the thymine. And you would be able to know that thymine means that it's DNA. If I ask you for the mRNA, we would base pair. So the mRNA would be GGC, but I can't use a T because I'm not allowed to use thymine in RNA. So this is where we use the uracil. I can use an A, can't use a T, I'm going to use the uracil here. And so this is transcription. What you just did was transcribe. You rewrote, you base paired to make mRNA. Remember, we're just working with one section here. Once mRNA is completed, the DNA re-zips. So that's one of the important things about DNA is that it closes back up and it stays in the nucleus. mRNA leaves the nucleus through a pore in the nuclear membrane, and the code is now complete. But we do need to translate it. So this is just going to be step one. Transcription is when you rewrite the DNA code into mRNA. So we really have to practice. What is transcription? Where is transcription? How do we transcribe? Who's involved in this? And so you want to make sure that you practice not only the steps, but also the transcription. You'll see at the bottom of page 50 that it does give you a sequence. However, that sequence that it gives you there is actually mRNA. How would you know that that's mRNA? If you see the AUG, this U actually means that it's mRNA. So here's a challenge for you. See if you can go backwards. If this is the mRNA, see if you can go backwards to the DNA. For example, what would base pair with A? If I'm building DNA, T base pairs with A. So take this time to complete the summary box that's there, and then we'll be ready to do some transcription in class.